Okay, I gotta start to make this video because I didn't know I was recording while I was doing this. So anyway, here's one example of how to design a power transistor, just a simple power transistor. Usually this drawing is just as reference to place it on one example, the amplifier, just to see how much space you have between the transistor. You don't want to have the power transistor way too close each other, so that might be create problems right there. So right now I know that the size of this transistor, power transistor, is the B is actually, once I'm going to show you right now, the B is from millimeters, from 19.3 millimeters up to 20.3 millimeters. So it makes sense just to round that number to a 20 millimeters. And the good thing about it is that 20 millimeters, a half of that measurement is 10 millimeters. So I can place a center. As you can see, there is a blue dot right in the middle of that line, the silkscreen. So what I do, I just place a circle. The circle is going to track that center of that line. As you can see, it turns red after it finds the grid, the middle grid of that particular line. As you can see, dx is 0.000 and dy is 0.000. So it's the center of that particular. If I move it around, as you can see, it's moving the number is 2 millimeters. I'm going to find the center of that particular line. So now we know that that's the center, so we can split the transistor to a half, so we can locate the center of that line. So we can actually also center out the middle lead of the power transistor, so we can relocate it correctly and place it in the correct manner. One sample, the pads, sorry, but I will say patches. What the hell I'm talking about patches? Okay, the pad usually on this power transistor is 5.45. So I think that it makes more sense just to round that number to 5.5, and there's just a few micromillimeters or mini millimeters, something like that. That will be G on this particular data from the transistor. So that will be G. Lead 2 and 3, it show you this pitch distance between the leads. So right now, if I look for the G, is 5.45. So we'll just round that number to 5.5. It's a lot easier that way. 5.5 is fine. The drilling hole of that particular transistor, I think, is D. Yes, it is D, right? D, and it says a 0.93 minimum to 1.48. The best practice here is just to keep it at 1.5, so you will have the hole not so small or not too big. So it needs to be a little bit bigger, so you will have no problem trying to fit the leads of the power transistor. So 1.5 is fine on this particular design. Right now, if I select the pads, it will illustrate that I look to the right of the working area. As you can see, the pad, the drilling hole is 1.5. That's fine. And the pad, the outer diameter, I think it's the outer diameter of the pad. Let me see. Hold on, give me a second. The outer diameter of the pad is 4.00 millimeter. That's fine. So you don't want them to be way too close each other. That's not good. So right now, 4.00 and 1.5, it should be fine. So one thing, you don't need to make this way too fancy. It's not really necessary. I always like to make it fancy, but it's not really necessary. Just look at the data. Okay, the C on this particular transistor is looking by the side of the is Z, so that it says 4.7. 5 millimeters is fine. 5 millimeters does not need to be perfect. So let's see, we got here. Okay, I gotta measure the whole thing. Okay, let me see. I have here, let me look at the panel. 6, that's too big, that's way too wide. Yeah, I gotta change it. Yeah, gotta change it. Let's make it smaller. Let's make it smaller. All right, I need it to have at least 5, or maybe. Okay, I gotta look at the. Oh, okay, there you go, right here. I see it. All right. I got a little problem here because I think I gotta make it even smaller. Yeah, because the silk screen cannot be touching the pads. So let's say if I can make it a 5.5 should be fine too. 5.5. Let me see. I got 6 because if you notice, I'm selecting the trays on the right of the working area. The properties is gonna illustrate you the length or the measurement of that particular trace. Basically, this is a silk screen. So right now I gotta make it smaller. Let's try to make it at 6 millimeters. Let's go with 5. Let me see if I can make it smaller. 5.5, it should be fine. 5.5. So right now I gotta do the same thing with the other one. Gotta move it. 5.5. Okay, that's fine. 5.5. Then I'm gonna use the same grid of these lines, because actually you can grab the blue round, I think I can call it like an editable thing, whatever tool, whatever, and then I go, damn, god damn, that shit scared me. Oh my goodness. All right, so I'm gonna move this down. I'm gonna use the same line as a grid, and then I'm gonna do the same thing here. There you go. Because I'm using these lines as grids. So right now we have 5.5 is fine. We got 5.5, and we had 20 millimeters in length. We got 20. It's fine. I mean, does not need to be way too fancy. You can make a little larger. It's not needed to be fancy, because and then you select the whole thing, and you can make a macro, build the group. So this is ready to be editable. I mean, ready to be saved. Ready to be saved. So, okay, I had the older. I think I already sent you the example. I already sent you the example. So I'm gonna save it. This one here. I'm gonna save it here. Correct. Okay. Correct size. Okay. That's a good thing. You can delete it if you want to. After you see the sample, you got it. You can delete it. It's fine. This is just I made the folder to throw there the examples, so you can look at it and analyze them. So, okay, are you wondering how did I make? Okay, the only measurement that I had to make it accurately was this one here, the U, letter U. That one is 6.3. And that might be really difficult to accomplish, to make it as accurate as possible. So there is one trick that I always do. One sample, I'm going to show you how to do it. One sample, I'm gonna place a pad. This needed to be a pad, no a silk screen. All right, we got a pad. I'm gonna delete this one here, so I'm gonna delete it. All right, no, not this one. Oh, okay, there you go. I'm gonna delete it. So I'm going to use the tool that we have here is tile arrange circular. So I'm going to use that tool, and then we have this horizontal box. We have the option and vertical. So I'm going to use the vertical option, and then on this little window I'm going to type the number 6.3 because it needs to be accurate. So I'm gonna press OK to enable that. So now, if we're going to measure the distance between the pads, it's going to have the correct number. As you can see, it's 6.3 millimeters, so it's correct. So what I do I use this as a tool, so to place that drilling for the transistor accurately with no errors on the PCB. So now that we have this grid right here, as you can see, if I press and keep the I think it's the left button of the mouse, is going to illustrate like a X, like a red X that is telling me that is right on the spot, right on the 0.0 grid. So right now, okay, I see something here. It says grid off, shift. Okay, I see something. I never tried that, but it says something about grid. Control equals grid off, shift equals half grid. Okay, I'm not gonna do that. I'm not gonna mess with that. I'm not gonna mess with that. All right. So right now, and then what I do, okay, well, I'm gonna delete this this drilling hole. This is a 3.5 millimeters drilling hole. So both number, they need to be the same. So that means that they're just gonna drill a hole through the PCB without having any solder area. So it's not gonna have any solder. All right, so now I'm gonna delete this one here just for the example. I'm gonna delete it. Yeah, I'm gonna leave it. I'm gonna delete this one too, so it's not really needed. Okay, so what I do, I grab this one here. This is going to be the master grid. I'm gonna call it the master grid. So I can move it around. He's gonna look for the grid that I wanted to place. One example, we got this silk screen, the circle. It will have the center. It's going to be centered out, as you can see. So I'm gonna place it. I'm gonna move it. This pad is gonna guide the other one. So I'm gonna place it right here, and you can see it's turning into like a red square. So I'm gonna leave it right there. Okay, hold on. There you go. Right now. So this is correct. Then what I usually do, I just delete this one here. I'm gonna split the group. Then I really don't need this pad anymore, and then I can edit this pad to be just a drilling hole. So drilling hole for the screw M3 and M4 screw is about 3.5 is fine. Okay, let's go with 3.5, and the other one 3.5. It is, there you go, we got 3.5, and then we can place this how you call it, the silk screen, just to illustrate that a whole screw, it will be placed there. That's the only function of this. It's not really needed. This is just I create these transistors as a guide. One sample, like I say already, I place it on the design to see how much space we had between those transistors. That's the purpose I do that. Also work as a guide for drilling. One sample, just like the honey badger, you place those transistors there, and then you can print a PDF file for printing, so you can use it as a guide for the drilling of the heat-sink. So also one important thing, that after you print out the PDF, try to compare with the actual PCB and place it on top of the printing of the guide to see if they are matching, because sometimes the software that we use for printing the PDF, virtual printing, sometimes they are not accurate, so they needed to be accurate. So that happened to me. I print a file so I can use it as a guide, and it was not accurate, so I messed up the whole heat sink. So, and then, well, okay, that thing happened, you know. Okay, so that's the way I do it. And then one sample, you wanted to place one sample. I'm gonna move this pad. Okay, the way I create a pad, at least the software is really helpful, because you can go, what the hell, right there, man, what the hell is that? Sometimes someone is writing me something. I don't know. Let me see. Trump? What? I'm gonna scratch my head. What the hell is going on here? Okay. Oh Jesus, guys. All right, let's go back to the video. All right. The pads. Usually, most of the time, the distance between the pad is 5.45, and just run that number to 5.5 is fine. Does not need to be perfect. The drilling 1.5 is fine too. I always say the word fine, but that's okay. That's okay. So You're wondering how I gonna place, how to create the 5.5. You can use the footprint wizard right here. We got the footprint wizard, and here you change the, it's horizontal. So you change the numbers of paths. We only need 3 paths. You change the distance between them, D. So let's type 5.5 here. 5.5. Hold on, what the hell? Okay, 5.5 millimeters. So that's good to go. And here you can change the size of the PC, or the pad. Sorry about that, PCB. What the hell? Okay, 4. Let's go to 4 millimeters. The outer diameter of the pad, and then the drilling is going to be 1.5. We got 1.5. I forgot to change it to pad and copper. Okay, change this layer to C2, really important. And also press F12 if you want the pad to have solder on both sides of the pad. Right now I'm going to place this. This is the guy. You can see this is the, it's splitting the, it's making a sort of like a mirror image of the part of the component. So right now I'm going to use this blue line, the blue dot, as a guide. So I'm going to place it. You can see if I grab the middle pad, this is the master guide, so I can place it anywhere. So I'm gonna use the line as a guide so I can move it. So right now it's centered out. I centered those 3 pads to the working area, so now it's centered out. So if I measure from one pad to the other and the center, is going to have the same number. So one example, I'm gonna place it, gonna make the measurements with the ruler. I'm gonna use the ruler here. I'm gonna measure from the middle to the other one. We got 5.5, and from here to here 5.5. So that's good enough. Here you can you wonder how did I create those to have the same distance between them. If I measure those leads, you can make it as artistic as you want. Okay, so from here, from this tip to the other one is 5.5, and from here to here is 5.5. So what I'm gonna do is gonna split this group, split the group. There you go. And then I'm gonna copy it. So I can clone this silk screen that is representing the leads of that transistor. So I'm going to clone it. I'm gonna use tile arrange circular. That's I call it the whole name. So I'm going to make 3 of them horizontal, and here I'm going to type 5.5, and that's it. And then I'm gonna press OK, and it's gonna generate those leads. So right now I'm gonna measure here one more time. We're gonna have 5.5 and 5.5, and then you're gonna grab this tip from this one sample. And you can see if I hold the mouse, the left, I think it's the left button of the mouse, and you drag it around, it's telling me that this is the master of the grid. So I'm gonna place it right on top of the guide that I have here. As you can see, it turns red, and then I can move it down. I'm gonna move this down in place, so you can see it's really accurate this way. Once you completed the whole thing, you can save it as a macro later. So that's one way to do it. So all right, this can be a little bit more fancy. I mean, it does not need it to be that fancy. This is just for guide. Usually for audio amplifier, it's gonna be like this. And the good okay, one last tip of the day. One sample, you are creating an audio amplifier. I'm gonna give it, let's go with 250. Yeah, one sample, you are making an audio amplifier and you wanna multiply them, but you want them to have the specific distance between them. You want to have to as accurate as possible. So one sample, I'm gonna use this guy that I have here. Yeah, I can delete it. That's okay. I can delete this one here. This is just a guy. Wait, I'm gonna delete this here. I don't need it. There you go. I'm gonna delete this one here too. All right, there you go. We got the transistor there. And yeah, I'm gonna use this one too. I'm gonna copy it. Okay, so one sample, this is the guy. I'm gonna place it right here. You can see, oh yeah, I forgot to tell you. You see, I wrapped the middle one. I'm gonna place it right here. So that will, they're going to be in grid, in 0.0 grid. One sample, this is just an example. All right, so I'm going to clone this transistor to the right. I think it's to the right. So I'm going to use the title, and then let's say I want to have 6 pairs, or 5 pairs. So I'm gonna add it here, horizontal, and then one sample I can move this. This is like a rocker. I think this is sort of like a rocker mouse, something like that. I'm gonna move it up. Let's say we have 5 pairs. Let's say that's 5 pairs. I think the distance between them is fine. Here, always try to keep square numbers. 26.5 is fine. So this is, we got 26.5, the distance between. So it's going to be really accurate to create in that particular matter. So now on the design, one sample. Sometimes you gotta think about the size of the PCB. One sample, you wanna think about how big is going to be the PCB. One sample, this is the extra PCB, and then you wanna have like an extra power PCB, and this is the actual PCB, 66 millimeters by 165.250. That's fine. You can be changed later. So and now you can move these macros. You can clone them one more time, flip it, and then you gotta adjust the grid. Snap to grid. Okay, that's good to go. I think it's good. All right, so now I'm gonna use this center. You can see I grab one of the middle pads to use it as a guide, so I can place it right here. It's not gonna be perfect, but yeah, you can see. And then I can move it down. So I'm gonna move this down, and then later you can adjust it, make it the distance between this line, the outline of the PCB. One sample, I usually do this. This is a little silly, but I move it down, make it flush with the outline line, and then with the outer line. Sorry about that. And then I just counted the times. One sample, 1, 2, 3, 4, 5. Let's go 6. And then I will. God damn it, Jesus Christ. And then I will do the same thing with the other one. I will move this up, make it flush with this line, and then 1, 2, 3, 4, 5, 6. So both power transistor, they are going to have the same distance between the outer line of the PCB, and they're going to be aligned correctly. One example, if I place the meter, it's going to have exactly a 90 degree perfectly between them. So then later you can add the emitter resistor and stuff like that, and other designs. Also, you can also see the center of the PCB. One example, this is this blue circle. It is what it does is indicate the half of that particular line. So one example, I can use it as a guide. I'm gonna place it here, move this line over here with the seal screen. I'm gonna turn this into a seal screen. So that's the guide. So I know that's the half of the PCB. So I can place one example, a coil, or maybe the trays or something like that. You want to have an accurate representation of the to have like a mirror image of both sides of the PCB. So to locate one example, filtering capacitor, you can place a filtering capacitor. One example, let's make one that is 7.5. I think I'm making this video way too long. All right, so let's go with 7.5. 7.5, and then the whole 1 millimeter is fine. 3.5, I'm gonna place it here. This should be C2, F12 for so have both solder on both sides. And then I need to find the center of this circle. Okay, most of the capacitor they have, I think, 80 millimeters in diameter. I think 80 millimeters. Hold on, what the hell I'm doing here? Okay, 80 millimeters. So I gotta look for the center of this particular. So this is the center. So I gotta place. There you go. That's the center, and then I'm gonna look for that center. We got it. It's done already. So that's the way I do. Okay, yeah. I'm gonna place the negative indicator. So I'm gonna place it right here, and then let's say this is just an example. I mean, there you go. Oh, yeah, that's fine. We got it. Then I'm gonna make this line thicker. This is the negative indicator for the capacitor, and that's fine. Okay, should be silk screen, no outline line. This is S1 silk screen. So I'm gonna create build the group so I can move it around, and then I can use this line to tell me that I can place component more or less like a symmetrical in the symmetrical matter. So one sample I'm gonna use this rotation, place it over here, and then it's not too good just to make sure that I got everything correct. So I can move it. I can use this line as a guide and the bottom one, and then okay, we got that. And then I'm gonna copy it. I'm gonna place it here, move it down. All right, so I can move it. I just counting. I mean, you can do also this trick. Place a line. Man, there's a lot of ways how to do it. Okay, place a line here to use it as a guide on sample. I'm gonna place it a little higher, and then I'm gonna use the grid of this pad to place it in the tip of that particular silk screen or outline, whatever. And then I'm gonna place the other one here and do the same thing. Use the guide. There you go. Delete it because I don't need it. And then I can move this capacitor forward, or depending on the way you want it. I mean, the way you want it on the design. So they will have the same symmetrical distance between. It's not really necessary. Sorry about that. It's not really necessary, but I like to do stuff like that sometimes, depending on the design, because sometimes in the design you cannot do that. You cannot make it symmetrical. So it's like the Honey Badger is not a symmetrical design. This is completely different. It's totally different, this design. All right, that's it. I'm gonna cut the video. I hope you liked it. I think I talked way too much. Well, it's good. It's good to see tricks and tips on how to work with the Spring Layout 6. There is more to it. I will try to make more examples or videos. All right, that's it.